In Module 3, you will learn about server and user administration fundamentals. What is the principle of least privileges and why is it important to an organization's security? How is role management, privilege delegation, and root access control set up for Linux servers? You will learn about roles, role services, and other features in Windows Server. You will research the existence of compliance regulations for server administration and complete an exercise to help test your ability to learn about current and future requirements in cybersecurity. Are you ready for the challenge? In this video, you will learn to describe the Windows components user mode and kernel mode and how they differ.
Hi there. I'm going to talk to you today about a few quick concepts for Microsoft Windows. Let's jump right in. Microsoft Windows, developed by Microsoft Corporation, has been around for a long time. Pretty much anyone who has used a personal computer within the last 20 years probably has some experience with Windows. But really the best part about Windows is it created the first graphical user interface that we're used to. So where you can go in and use a mouse to point and click instead of having to type in commands. And it was designed for IBM compatible PCs. So obviously Macintosh and Apple devices will run their own operating system. Windows will run on what we call IBM compatible PCs. IBM, as many of you may know, created the first personal computer in the early 80s. Approximately 90% of PCs worldwide run some version of Windows, and servers as well run versions of Windows as well. So it's something that many of us are very familiar with. So there are a couple components associated with Windows, or there are a couple components that Windows uses. They have a user mode and kernel mode components. User mode is really what you see when you are opening an application, when you're using Microsoft Word or you're surfing the web with Chrome or Firefox or anything like that. You're really accessing user mode. And there are drivers that are used by that to create that I/O, that input/output that you're leveraging when you use an application like Microsoft Word or, as I said, a web browser. And then there's the kernel mode, which is kind of the underlying technology within Windows, where you have different processes and threads that actually control the applications that you're leveraging within Windows and within the user mode of Windows. So let's talk a little bit about the user mode. So when you start a user mode application, Windows creates what it calls a process for an application. Anybody who's gone into Task Manager can see when you have applications that are running, you will see those processes running inside the Task Manager that will tell you things like how much memory it's using, how much CPU, and CPU is your processor, how much processor it's using as you use that application. The nice thing about applications is they're really pretty segmented from each other. So when you start an application, that virtual address that is created are private. So it's segmented from other applications within the environment. So one application can't alter data that belongs to another application. Each application runs in what we call isolation, and if that application crashes, it's not going to bring down the entire operating system. It's only going to bring down that application. So other things that are going on are not affected by that crash. If we talk about kernel mode, everything that runs in kernel mode contains a single or shares a single virtual address, so that kernel mode drivers are not isolated from other drivers and from the operating system itself. So if a kernel mode driver accidentally writes to the wrong virtual address or to something else within the operating system, that data within the operating system could be compromised. So if a kernel mode driver crashes, the entire operating system would crash. So you may have seen that where you get the blue screen of death, as it's commonly called, when your operating system stops and you have to reboot. That's typically caused by a kernel mode failure or a driver within the kernel mode writing to virtual address that would cause an issue with the operating system.
In this video, you will learn to describe the NTFS and FAT file systems used by Windows.
Okay, so let's talk about the different file systems that are prevalent within Windows. A file system is what enables applications to store and receive files on storage devices. When we're talking about storage devices in Windows, we're mostly talking about a hard drive. So what's installed in your computer, it could be a spinning platter, which is a mechanical device, or it could be a SSD, a solid state drive, which is a non-mechanical device that stores that data. Files are placed in what we call a hierarchical structure. So you may have folders within folders within folders. And the file system will specify naming conventions for files and the format for specifying the path to a file in that hierarchical or tree structure. Just for definition's sake, a file is a unit of data in the file system that a user can access or manage. So a picture file is one file. It might be a JPEG or it might be a PNG file, but that's what we consider is a file. And every file has to have a unique name in its own directory. What you'll notice is if you copy a file within a directory and paste it in the same directory, it will put a number behind that file name just to show that it's the same file, just a different copy of it. And a directory, and you may be used to having it be called a folder within Windows, is a hierarchical collection of directories and files. And we'll talk a little bit more about that as we go on. So there are really a couple different types of file systems that are used within Windows. NTFS, or New Technology File System, is the one that is most prevalent today on operating systems like Windows 10, Server 2012, and 2016. That NTFS is what most of your drives will be formatted as. NTFS has been around since 1993, and as I said, it's really the most common file system for Windows. Both end user systems as well as servers that are running Windows will run the NTFS file system. There's also another kind of operating system that was really previous to NTFS, which is called File Allocation Table, or FAT. It's a more simple file system that's been really used since the 80s. And you may see different numbers associated with that FAT operating system, or excuse me, that FAT file system. And those numbers that precede the FAT or file allocation terminology refer to the number of bits used to enumerate a file system block, so FAT16 or FAT32. Mostly where you will see file allocation table file system is on removable drives. So if you have a USB drive or even a CD drive that's writable, it would typically be formatted as a FAT32 file system. And FAT32 can be used for devices that are less than 32 gigabytes in capacity. As we saw, hard drives get bigger than that. We needed a new type of file system, and that's where the NTFS came in. And now FAT is mostly used for smaller drives and smaller removable storage devices.
In this video, you will learn to describe the Windows directory structure and how Windows handles the separation of 32-bit and 64-bit applications.
So let's look at a typical Windows directory structure. And most of you who have seen Windows before have probably seen that everything is stored on normally the C drive. I don't know why it was called the C drive, but that's just what we call it. So your main hard drive is typically called your C drive. And these are the kind of standard file structure you will see on a Windows 10 device. So you'll have some folders that are hidden, and when they're hidden, that just means that they're not accessible to the end user unless you actually go in and unhide them within the control panel. So those are folders that Microsoft says, you really don't need access to those, so we're going to hide them from you. And the main one that's hidden is called perf logs. And it holds performance logs, but typically it doesn't really hold anything. It's usually empty, but it is a folder that is one of them that's in the common directory structure off your C drive. And then you have kind of the meat of what's on the C drive, which are your program files and your program files x86. So On newer operating systems that can address more memory, we went to a 64-bit operating system. Some of you may remember that when Windows first came out, it was a Windows 3.1 was actually a 16-bit operating system, and then Windows 95 became a 32-bit operating system, and we had various versions of Windows operating systems, both 32-bit and 64-bit operating systems. And the real difference between a 32-bit and a 64-bit operating system is the amount of memory that can be addressed. As applications came out that needed more memory to run, operating systems increased their bit to 64 in order to address additional memory. 32-bit operating systems can only address 4 gigabytes of memory, and for modern applications, that's just really not enough. So with Windows 2000, we started seeing operating systems that were 64-bit, and then XP and Windows 7, and then finally with Windows 10, Microsoft actually stopped releasing 32-bit operating systems, and Windows 10 is only available as a 64-bit operating system, and most of your server architectures as well are 64-bit. So, and the reason I go into that level of detail is because of those two different program files. So program files will store your 64-bit applications. If you have a 32-bit operating system, you won't have a program files x86 directory, because all of your applications will be installed in the program files directory. On a 64-bit edition of Windows or a 64-bit operating system, your 32-bit applications will be installed in program files x86, and 32-bit applications can run on a 64-bit operating system. They are just separated, so you'll see where they're installed differently. And then you also have a folder called program data, and those are files that are accessed by computer programs regardless of what user is logged into the system. So they're really files that the applications that you run need in order to work effectively, independent of any user that might be logged on. And then you have your user directory. This is where your user profiles are stored, and each subfolder will be a different username. So as an example, all Windows operating systems will have a public folder. So this is where end users might be able to share files. So if you have multiple people logging into a system, they can put something in public and everyone would have access to that file. And then you will have, in addition to public, under the users folder, you will have each username of people who have logged onto that system, or I should say who are authorized to log onto that system. So user files are typically stored in there. You may have lots of folders under the username directory. So you would have a documents, my documents folder, you'd have a pictures folder, a music folder. Anyone who's seen a modern Windows operating system will have noticed that. And then you will also have an app data folder. This would be like your program data folder, but for application data that is specific to an end user. So if you have a custom template within, say, Microsoft Word, it would be stored under your username and then the app data folder in order to separate it from other users who may log onto the system. And then in addition to that, you'll have your Windows system directory. And this is where Windows is actually installed here. And you'll have mainly 3 folders under that: your system 32, and your syswow 64. These are file or folders that really are the core features of Windows and the Windows API. So anytime a program asks Windows to load what we call a dynamic link library file, and it doesn't specify a path, these are the folders that are searched. So this is where Windows stores all the kind of system files that are needed to run Windows and provide the graphical user interface to the end user. Your system folder stores your 16-bit DLLs, and really will be empty on 64-bit editions of Windows, but the system folder is still there on 64-bit operating systems. Your system 32 will store either 32-bit or 64-bit DLL files, and what that really will depend on whether you're on a 64-bit or 32-bit system. And then your syswow 64 will only appear on 64-bit versions of Windows and store your 32-bit DLLs. And so that's really what you'll see when you open up a common C drive on a Windows system, either an end user system or a server system. These are the folder structure that you'll commonly see on a modern Windows operating system.
Hello and welcome to Using Your Windows Lab Workspace. We're excited for you to take these next steps in your skills journey. The labs in this course and other courses provide you with a virtual, hands-on lab environment where you can boost your skills by practicing what you've learned in your course videos and readings. Your lab space, also known as a guided project or the My Cloud Workspace window, contains all the software you need to successfully complete your lab tasks. You'll also open a lab instructions file. For your best experience, we recommend displaying your lab space and instructions side by side. To access your hands-on lab, first open the item in the course for the hands-on lab. If the lab instructions display in a new tab, hover over the tab and pull the tab down onto the desktop. You can drag the window edges to resize the window to about 1/3 of the screen size. You'll return to this window later. Return to the course screen and scroll through the displayed course lab instructions. Select the checkbox to accept the Coursera Honor Code conditions. Then click the Open Tool button. Next, you'll see the Coursera Guided Project window. This window may take a moment to display. The displayed My Cloud Workspace window is divided into two panes. The left pane is named the Cloud Workspace window, and the right pane is named the Instructions window. You won't use this Instructions window. Now, you can expand the Cloud Workspace pane on your screen's left side using one of two methods. Drag the vertical slider between the Cloud Workspace and the Instructions pane to the far right side of the screen, or click the Expand Cloud Workspace window button displayed on the top right of the left pane. Take a moment to view your lab window. You can click the Lab Window Resolution drop-down arrow to adjust the size of the on-screen icons in the Cloud Workspace. And next, let's adjust your browser windows to see your Cloud Workspace and lab instructions side by side. On the Cloud Workspace lab window, hover over the double box icon located in the top right of the browser window to reduce the size of your window. Move the window to the left side of the screen. Now, drag the window's right edge so that the Cloud Workspace lab window uses about 2/3 of the available desktop space. Next, select the browser window that displays your lab instructions. Drag the Instructions window so that the window is to the right of the Cloud Workspace lab window. Now, you can perform the lab tasks in the Cloud Workspace window while using the lab instructions. After completing the lab, select Leave Session to close the Cloud Workspace window, then close your lab instructions using the option available for your browser. Also, before you begin, here's some extra information you need to know. Each time you connect to these labs, Coursera creates a fresh new environment. Data or files you saved in a previous session are no longer available. To avoid losing your data, plan to complete your lab tasks in a single session. These labs are timed to provide enough time to complete lab tasks, but if you leave the lab session unattended, your lab may time out or end. Now, these setup instructions used a Chrome browser within Microsoft Windows 10. Other browsers and web browsers on Mac or Linux computers may use different navigation. You're now lab ready. Let's get started.
In this video, you will learn to describe authentication and authorization within Windows Access Control, define Windows privileged accounts, describe the principle of least privileges.
We're going to talk about role-based access control and permissions in Windows. And Windows really
approaches access control in a couple different ways, and those are really about authentication and authorization. So once a user is authenticated, the operating system itself determines what permissions the end user has to access a resource. And when we say a resource, that could be something like a file on the system, a folder, anything that's on the system. We'll talk a little bit later about Active Directory, which really moves the authentication and access control to a server side, so that once you're authenticated on a server, you have access to network resources and those kind of things. But for right now, we're just talking about local access control. And in that access control model, we have what are called users and groups, which are security principles. So principle in the context of you know, a person, as opposed to a principle like you know, a guiding principle or something. And those security principles have rights and permissions that inform the OS what each user and group can do. So when we're talking about the access control model, you could have a user that is an administrator, and they would have pretty much access to everything on the system. You could have a user that is a guest user, and they would have limited access, or you could have some level of access in between that, where they have access to some things but not other things. And those can also be divided into groups. So as an example, administrator is a group which can have multiple people who sign on to a system as part of that group. The security principles, meaning the user perform actions on an object. So they might save a file, they might create a file, they might delete something in a folder, those kind of things. And those are really what are being dictated by the access control and security in the Windows operating system. Resources that are shared by multiple security principals or multiple users use what we call ACLs, or access control lists, to assign permissions, and they enforce access control in a couple of different ways. They deny access to unauthorized users and groups. So if I have a folder that is only available to the administrator group, only those folks are going to be able to get in there and do things to it, and other people who sign onto the system will not have access to it. They also set limits on the access that is provided to authorized users. So I can really control what kind of access any user or group has within the system, whether it be the times that they can log in, what they can see when they log in. That all can be controlled based on the permissions that are set within the operating system. So now let's talk about privileged accounts. Privileged accounts are accounts that have direct or indirect access to all of the assets in an IT organization. As I said before, we're going to talk a little bit more about Active Directory, which is really how that's controlled at an administrative level, so that I can control all the machines that log into my network, and I can control all the folks that log into those machines. But I can also have administrators that will control only their system. So administrators configure Windows operating system to manage control for multiple roles and uses. And we go by the concept of the principle of least privileges. So, and as Wikipedia says, the principle means giving a user account or process only privileges which are essential to perform their intended function. And this is really important when we talk about security. One of the main concepts of IT security is access control, and making sure that people who don't have access to privileged information, or let me say it a different way, making sure that people who need access to privileged information, such as HR records or customer data or whatever it is, depending on the industry where you're working in, those are the only people that can access that data. And it's really important because with user privacy laws, and we have regulations like HIPAA and GDPR in Europe, it's really important that only people who have a need for particular data are able to see that data. In addition to that, it also provides better system stability. So not only are you protecting the data, you're also making the operating system and the hardware itself more secure, because you're not giving people access to things that they don't need to, like installing applications, installing drivers, anything that could potentially harm the system in the environment. And this leads to better system stability, or I should say better system security, excuse me, because you are controlling not only what folks have access to and what they can do on the system. That gives a much better secure and more stable system, because there is less variance in the environment. And this leads to easier deployments as well, meaning savings of time and money for the environment, because you are not have a tremendous amount of variance and everybody doesn't have access to do things on their own system. So it's all controlled from a central location and provides much more control from an administrative from an administrative perspective, which leads to the three things we talked about: better system stability, better system security, and ease of deployment as well. So when you talk about access control, there's really four main concepts that we're talking about. We're talking about permissions, we're talking about ownership of objects, the inheritance of those permissions, user rights, and what we call object auditing. And we'll go into a little bit more detail on each of these things.
In this video, you will learn to define local users within Windows, describe Windows security management considerations.
We're going to talk about now our local user accounts. And local user accounts are accounts that are stored locally on a Windows workstation or a server. So that's anybody who logs into the system but may not necessarily log in to get network resources. So all they can really do is access things that are local to that particular PC. So think of this as your home PC that may not be connected to anything other than the internet. You're not connected to corporate resources. You just have your own local resource that you are able to do things on. And there are several accounts that get created by default on a Windows account, and they're really divided into a couple different groups. One is the default local user account, so that would be the administrator account, which has full access to everything in the local environment. You have your guest account, you have your what's called the help assistant account, and your default account. Your help assistant account and your default account are really accounts that Windows just creates, but are really not used very much. Most of your users that log into a system will be part of the administrator account or the guest account, and for the most part, that's what folks use. By default, on a local system, you're most of the time going to log in as an administrator. You have control over your own system. You're able to install applications and those kind of things. We also have a couple of accounts that get created that are called local system accounts. That's you're actually called the system account, the network service, and your local service. These are accounts that are not visible in the environment, so you're not able to log into them as a user. These are things that are really under the covers for Windows and allow Windows to do things in the environment. So as an example, the system account will run services and run things on the local machine without you having to log in to do that. So it may run things in your task scheduler. It may do other things in the environment in the local system that don't need to be seen or are just not part of the local user account and are just done under the covers. So there's really some security considerations that you should think about for a local user account. And all of those local user accounts are located in the users folder. So if you look at it, they would be in C:users, and that's where their data by default is stored. You know, there still are security considerations that need to be taken into account when you're talking about local systems, non-AD systems, and as I said, we'll talk about AD a little bit more. But you want to restrict and protect those local accounts with administrative rights so that people who can get into the user's folder can only see their own thing. So you don't want, if you have on a multi-user system, me to be able to see your files and vice versa. You want to control access to those. In addition, you want to, of course, use your password requirements, which we'll talk about as well. And you want to enforce local account restrictions for remote access. So if you're talking about just a local system, you want to turn off things like remote access, or certainly control remote access so that someone can't get into your device and make changes to it. And you also want to deny network logon to all local administrator accounts. So if you're working in a corporate environment or a professional environment, local administrator accounts should never have access to network resources. That should all be controlled by whatever your directory service is, and we'll talk about Active Directory in a little bit. The other thing is, and this is probably the easiest thing, is create unique passwords for local accounts with administrative rights. So you want to make sure that you enforce password complexity, you enforce password requirements for length, and things like how often the password will expire. All those things will help make the local system more secure.
In this video, you will learn to define features of the new Windows 10 Security app.
Okay, so now we're going to talk about Windows 10 and the security app that is part of Windows 10. So Windows 10 is really the predominant operating system that you will see in most organizations now. You'll still see quite a bit of Windows 7, but most, or I should say many organizations have moved to Windows 10 at this point. Now, there are multiple builds of Windows 10. As you'll see, the Windows Security app came out with build 1703, which is, I think, the second public release of Windows 10. But Microsoft has basically said Windows 10 is our operating system going forward, and we'll just have incremental builds of Windows 10. So I think the current version is 1903, and they do different release schedules, but for the most part they have about 2 major releases a year. They have a fall release and a spring release, and those are still Windows 10. They are just different builds of Windows 10. And the Windows Security app came around in version 1703, and it includes several things that really were taken, or many organizations used other applications to solve these problems. So one of the main things that Windows has included now with Windows 10 is virus and threat protection. So many organizations are moving towards Windows built-in antivirus as opposed to subscribing to services like McAfee or Symantec or some of the other ones out there. It is now built into Windows 10, and it seems to be a pretty good AV. It includes Windows Defender Exploit Guard, and it also includes sign into Microsoft OneDrive if your organization uses OneDrive. It also does things like account protection. So you will notice it allows you to do things like setting up a PIN instead of using a password, or it integrates with your fingerprint reader to protect those things that may be hardware-based as well. It also provides firewall network protection, so it controls the firewall settings on your local machine. It also does what we call app and browser control. So it has things like what is called Windows Smart Screen, which is a feature that will not allow you to install applications that have not been approved or vetted by Microsoft. So it adds another layer of protection to make sure it's a known publisher or known developer of the application you're trying to install. It also has some device and performance health features, so provides you information about drivers, storage space, Windows update issues, anything to make the system more usable and provide health information about the system is all contained in the Windows Security app as well. And then for home users, it includes family options like access control to allow parents to control what their children are seeing on the PC, and allow parents to have better insight and control over what their kids are doing on the family PC.
In this video, you will learn to describe Active Directory, describe Active Directory features.
Okay, so now we're going to talk about Active Directory, and Active Directory is really the predominant directory system that you will see that most enterprises use. If they don't have a homegrown directory, they're probably using Active Directory to control users and permissions and those kind of things. Active Directory, or AD, is really a system that stores information about things on the network and makes that information easy for administrators to and users to find. So it will control things like your network folders, network printers, anything that a user may need to be able to get to do their job can be controlled by AD. And AD stores that information about those resources as well as permissions and controls the permissions as to what you can get to. What we're seeing now is many organizations, IBM included, is moving to what we call Azure Active Directory. So instead of having physical servers on site, they're moving to a cloud-based directory service. And Azure Active Directory is Microsoft's cloud-based directory service. So when I log into my laptop, it's actually logging into an Active Directory that sits on Microsoft's cloud and provides permissions that have been set by the AD administrators within IBM that are logging into their AD console through the cloud. So there's nothing on-prem for IBM within Active Directory, and many organizations are moving to that because it's more convenient. The objects that are included in Active Directory are things like servers, volumes. So when we say volumes, that's a driver, a folder, printers, and network and computer accounts. So Active Directory will have both a computer account as well as a network account. So really what this gives Active Directory the ability to do is control both of those things. So even if I have an AD account, if the computer that I am logging into does not belong to AD, does not have an entry into the AD, I will not be able to log into Active Directory, and vice versa. So if I have a computer account that is on AD but not a user account, obviously I won't be able to log into AD, and I won't be able to log into that computer either because that computer belongs to Active Directory. The nice thing about Active Directory security is really integrated into it through authentication. So when I type in my password or use my fingerprint, I'm accessing the Active Directory, which tells the resource that I'm logging into, in this case a laptop or a desktop. It tells that machine what things I have access to. So can I get to this server? Can I get to this directory? Can I get to this printer? And that's all done through that policy-based administration, which is part of Active Directory and which is controlled by your Active Directory administrator. There are some features of Active Directory that might be interesting to discuss, and really the features of Active Directory and what Active Directory really is a set of rules or a schema, and that really controls what end users have access to. So the rules are these things that are controlled by the AD administrator, which tells groups or users what they can get to. It has multiple hundreds, frankly, of settings that can really provide granular control of what users can do in an AD environment. It also controls things like your password policy, your password complexity. Anything security related is controlled through Active Directory. It also has a global catalog. So as a user, I can look at what things are in the global catalog, and that will tell me if I have access to it, what other users, what other machines, what servers I have access to, what printers might be available for me to print to, and those kind of things. It also has a query mechanism, so you can go in and search Active Directory for things like servers and printers and other resources that you might need. And then it also has a replication service. So if you have a large Active Directory, or if you want to protect your Active Directory, that replication can go to multiple servers. So you may have AD servers placed geographically within your environment to spread out the load between AD servers. Now, as I mentioned before, many organizations are moving to a cloud-based AD, Azure AD, and then that requirement for replication goes away because it's all done on the back end by Microsoft.
In this video, you will learn to describe and differentiate Active Directory account types, discuss security considerations for Windows account setup.
Okay, so now let's talk about Active Directory accounts and security considerations around Active Directory accounts. So there are several different Active Directory accounts, and they are similar to your accounts that we talked about earlier that are local accounts. So you have your administrator account, you have your guest account, and you have your help assistant account, and then a fourth one called your KRB target account or KRB TGT account. The administrator account and guest account are very similar to the local accounts that would just control access to things in the environment. Your help assistant account is an account that may be logged into if someone needs to remotely help your PC, and the KRB TGT account is really an account that is not one that is logged into. It's more of a system account that may be used in the environment, but it's not something that end users are really going to log into. Also, within Active Directory, Active Directory allows for settings of local accounts within the Active Directory. So when I, as an AD administrator, provide someone with a PC, what happens is, since that PC belongs to my Active Directory, those default local accounts will be managed in the Active Directory. So even if I'm an administrator, or I should say if I'm a user in Active Directory, I may not have administrator rights on my own machine because that's all controlled via Active Directory for my local machine. So an end user may not have full control over their own PC once it resides in Active Directory, and in fact, most end users don't have full control because we want to, frankly, take as much control away from them as possible so that they can't do things that could be harmful to the environment. And it also will manage those default local accounts in Active Directory as well. So if I want to turn off the guest account, I can do that. If I want to add another account on a system, I can do that as well. And I can do all those things remotely from Active Directory. The other thing that Active Directory accounts do is manage domain controllers. So obviously you would have to be an AD admin to do that, but that's someone who would control login credentials and how people log into the system. So let's talk a little bit about protecting domain accounts and how you do that. And again, when we're talking about domain accounts, those are things that accounts that can access things on the network. And one of the things you want to do is separate your administrator accounts from your user accounts. So they're going to be, in fact, most people are going to log in as a standard user and not as what we call a privileged account. So a privileged account is administrator accounts that there are various levels of administrator accounts. So if we talk about a privileged account, you may have multiple levels of that. Even though someone belongs to an administrator group, they may have different administrative levels within that group. So as an example, you have three different levels of administrator accounts that you may want to do in your environment. So at a minimum, you want to create separate accounts for domain administrators, enterprise administrators, or any other administrator that it needs to have access to systems and resources in AD. That's the bare minimum you want to do. So you have administrative accounts that have various levels of access. Better is to create separate accounts for administrators that may have more reduced administrative rights. So I may have access to particular workstations or particular resources in the environment and not access to all the resources in the environment. And those are usually segregated by what we call OU. So within Active Directory, you will have OUs or organizational units. So I may have administrator access to one OU, but not another one. So think of an OU as a department, and that's making it much more simplistic than it is, but you could have a marketing OU, you could have a sales OU. OUs can be set up for a variety of different functions within the organizations, but certainly when you're looking at protecting the environment, having administrators that don't have access to all your OUs is better than just having administrative accounts. And then ideally, if you're talking from a security perspective, you want to have multiple accounts, separate accounts for an administrator who has multiple job responsibilities. When I go into organizations and talk to customers or see how customers do things, many customers have accounts that have, or they should say many customers will have multiple accounts in their environment. So they may have an administrative account that has access to one thing, and then they'll have an administrative account that has access to other things, and this just protects the environment and makes things more secure. And those different accounts will have different what we call trust levels within the environment to make things more secure. And then, of course, you have your standard user accounts, and these are just your standard business user, such as email, web browsing, and using particular what we call line of business applications. So if you need to use an HR application or something else, your account may have access to that, but not be able to control things on your PC. And those are the majority of end users will just be standard users. Okay. So another way or a discussion around protecting your domain accounts and restricting those domain accounts is to create workstation hosts without internet and email access. So these are for folks who may need to manage job responsibilities that require administrative rights from a particular workstation, and they may not have physical access to servers. So, I may need to log into a server, but in order to protect that server, what customers might do is, or what folks might do is create a terminal or a PC, or have a PC there that it can only access particular things on the network, so access particular servers, but not be able to access the internet as a whole. And that way I'm protecting those particular environments because, or those particular servers, those particular AD resources, because the computer that I'm using to access them does not have internet access. So I can't accidentally infect those servers by something when I'm, surfing a website and inadvertently move something to one of those servers. So, and that's really a bare minimum. So the minimum is to build those administrative workstations that don't have internet access, including things like web browsing and email. And then even better, we want to make sure that administrators on that system can't be part of the local administrator group so that they can manage the servers that we talked about, but they can't manage the local system they're logging into in order to bypass those restrictions. Because remember, once you're an administrator on a local system, you have full control over it and you can change settings. So we want people to have access to the servers that they're managing, but not be able to bypass the protections that we turn on. And then ideally, you can restrict workstations from having any network connectivity except for the servers and domain controllers that the administrator accounts are used to manage. Now, practically, I've seen very few organizations that do anything that we would categorize as better. I've never seen in organizations where they have to log into a target or a specific workstation that only has access to servers and domain controllers. Most organizations will allow people to log in from their local system, and they trust those people who manage their environments to not do dumb things and put their environment at risk. But these are just some of the things that we recommend as being good security practices. Certainly in high security environments like government or other industries that require that level of security, these are probably things that you want to think about. Okay, so one of the next step in protecting your sensitive domain account is to really restrict the administrator login access to servers. So And what we mean by this is you're going to restrict administrators from using their admin accounts to sign into what we call lower trust servers and workstations. So let me put that in real-world context. So if I'm a domain admin, I'm not going to log into my local system to check my email and to surf the web and to write my resume as my domain admin. So that's what I talked about before about having multiple accounts. You'll have users that have their standard user account, and then they'll have their domain admin account. And that's really the best practice is to not have those people log in with their domain admin account. When I come into work, I'm going to log in as my standard user account, and only when I need to use my domain admin account will I use that account. And so when I'm logging into the domain controller, when I'm logging into a server to do some work on it, or to do anything like that, I would then and only then would I log in with my domain admin credentials. And there's some guidelines that are recommended to do that. And the first one at a bare minimum is to restrict domain admins from having access to servers and workstations. So what we mean by this is computers that are not in particular OUs that are controlled by Active Directory, they're not able to log into. So it provides a layer of protection there to do that. And then even better than that is to restrict domain administrators from non-domain controller servers and workstations. So anyone who's a AD admin or a domain admin, they won't be able to log into things that are not part of the domain as well, and that provides even more protection. And then we want to, the ideal thing is if you have server administrators, do not allow them to sign into particular workstations. So if I'm a server admin and I control Windows servers, I don't want to be able to log into workstations other than my own, or the organization doesn't want me to be able to log into workstations other than my own. And the only reason I would log into my workstation is just to do my day-to-day job, and that's really the ideal security for domain accounts. Okay, so let's talk about the fourth thing we can do to restrict and protect sensitive domain accounts. So one of the things that we want to do is disable the account delegation right for administrator accounts. So what that means is because Active Directory accounts, user accounts, can be trusted for delegation, meaning I can delegate someone to do another account to do something, that really gives the ability to impersonate an account that authenticates to other resources on the network. And in order to avoid that, you can configure sensitive accounts within Active Directory to not be delegated, meaning that I can't delegate that to a different account. I have to only log in with that account, and that is the only way I can do things in the environment, and that prevents things from potentially impersonating other accounts that would cause an issue. And you only need to do this with sensitive resources. So, your domain controllers, any servers that you deem as sensitive, that would require that you turn off delegation. But for normal servers that people need to log into, delegation is fine.
In this video, you will learn to define types of Active Directory groups, describe an overview of features and tools within the Windows Administration Center.
We're going to talk now about server management with the Windows Admin Center and leveraging Active Directory groups or security groups to manage accounts and to manage servers. For Active Directory, there really are two types of administrative responsibilities: service administrators and then data administrators. So service administrators are managing things in the environment, such as what I have access to, what I can do on my device or with resources on the network. And then there are what we call data administrators who are actually managing access to the data in the environment. So things like customer records or employee records or any kind of sensitive information that the average end user doesn't need access to. And there are two types of groups within Active Directory by which we manage those. So those are distribution groups, and those are used to create email distribution lists, and then security groups, and those are used to assign permissions to shared resources. You know, everybody in Active Directory is going to be part of a distribution group because most organizations are going to control their email through Active Directory. Sign into AD, and that's how your email is delivered to that particular machine. You know, I log into the machine, launch, as an example, Microsoft Outlook, and then because I've logged into the machine as my AD account, the machine knows, hey, this is this person. Here's the email that is assigned to that person, and so my email is delivered to me through Outlook through Active Directory, essentially. And then there are security groups which are assigned permissions to shared resources. And when we say that they're used to assign, if I'm part of a security group, that means that I have access to particular shared resources. The AD administrator is the person who actually assigns the permission, but the security group is what controls the permission. So through a security group, I have access to particular servers, particular printers, whatever is part of that security group in the environment. And then let's talk about scope around those groups. So any group that is created within Active Directory is characterized by a scope, which means the extent that that group is a part of the domain and what they can do in the domain. And there are three scopes that are defined by Active Directory: universal, global, and domain local. So, and really, this level of detail is more than most people would need to know about Active Directory. We're really getting into the kind of the minutia here, but just things that are interesting to know about Active Directory. So when you first create an Active Directory domain, or when an organization creates an Active Directory domain, they have these default groups, such as the domain admin groups, and that's a security group that controls the domain, basically. And those predefined groups help control access of those shared resources and those specific domain-wide administrative controls within Active Directory. The Windows Admin Center is new with Windows Server 2016. And that is a browser-based management tool that you can manage your Windows servers. It gives you really full control over all aspects of the server infrastructure, and it's really useful in managing servers on private networks because they're still connected to your domain, but they may not be connected to the Internet. Many organizations will not connect their servers to the Internet because they worry about breaches and those kind of things. So the Windows Admin Center allows you to control those servers remotely, even if they're not connected to the Internet. And that is really one of the ways that organizations manage those servers is through the Windows Admin Center. They may have other tools as well, but that's one of the main ways that servers are managed through a Windows environment and an AD environment.
In this video, you will learn to define Kerberos authentication, describe the use of Windows Server logs.
So we're going to talk about security and compliance and spend a little bit of time on that within the context of the Windows operating system. And one of the things that we probably should become familiar with what's called Kerberos authentication. And it's an authentication protocol that it's used to verify the identity of a user or a host. And Windows uses it mostly around AD. So when someone logs into a system that is connected via AD, most AD systems will leverage Kerberos as the authentication protocol that secures the AD or the Active Directory in order to authenticate that end user or that resource on the AD. What's called the Kerberos Key Distribution Center, it's integrated with part of Active Directory, other Windows Server Security Services, and it uses the domain Active Directory Services database. You really don't need to get to that level of detail. What is really important is to understand that Kerberos is the predominant mechanism which is used within Windows for authentication and for securing the Active Directory environment. That's been around for a long time. The key benefits really of Kerberos include things like delegated authentication. So authentication can be delegated to different resources in the Active Directory forest between other resources and other users within the same AD. Single sign-on capability. So when I sign on to AD, anything that leverages that AD sign-on, I've automatically signed on to as well. So I don't need to then sign on multiple times to access resources within that Active Directory environment, which makes things a lot easier and a lot more convenient for the end user, but still maintains security. And then interoperability. So when I'm leveraging Kerberos, it really doesn't matter any of the characteristics of the resource that I'm going to, because as long as they are part of AD and I've authenticated to AD, I can get to those resources within the AD, which makes things easier for the end user as well. And then it's more efficient to have that authentication built in. So by leveraging Kerberos, which is built into AD, we don't have to have a separate authentication service. We don't have to have anything like that. Although that being said, many organizations are looking at two-factor authentication or have already enabled two-factor authentication within their environment to provide another layer of security. And two-factor authentication, just real quickly, is leveraging, say, your AD password and then maybe a third-party authentication service like Google Authenticator, or Microsoft has an Authenticator, or IBM has a identity and access management solution that provides those kind of capabilities to make things more secure. But for the most part, AD leverages that Kerberos and that single-factor authentication. And then the final thing is mutual authentication. So again, providing that ability to log onto multiple things with just leveraging that same username and password that's built into Active Directory. Now we're going to switch topics real quick and talk about Windows logs, Windows Server logs. And server logs are important when you're talking about security, when you're talking about managing Windows servers, because that's really where all your information is held within a Windows environment. Logs are records of events that happen in the computer, and those logs, and server logs are no different than logs that are held on a desktop or laptop. Just any Windows system, or frankly any system, regardless of the OS, is going to have logs. We're just talking about it in the Windows context right now, but they are events that happen either by a person or a running process. And the purpose of those is for you to track what happened and to troubleshoot problems, but also it's to help to investigate security events. So when we talk to customers about how to manage their environment, logging is a very important component of that. And one of the things that we do is help customers aggregate those logs and analyze those logs to figure out what events may have occurred that led to a potential breach or a security event or anything that is out of the norm that needs to be investigated. From a Windows perspective, the most common locations for those logs is what's called the Windows event logs. And it contains logs from the operating system and lots of other Windows applications that may be run on that server, such as SQL Server or IIS, Internet Information Server, which is Microsoft's web hosting application. And they use what's called a structured data format, and it really makes them easy to search and analyze for. Other logs may be written in what's called text format, so you can go in and actually just read those manually if you want to. But many organizations will leverage a log aggregator to make sure that you can see things easily. So if we look at this slide, this is kind of an example of what you would see with the Windows Server log, and these are contained in the Windows Event Viewer. The Windows Event Viewer lets you look at, in a single place, the Windows event log and search or filter for particular types of logs that you might be curious about. And really, when we talk about logging, we're talking about it in a broader context of just one machine. We're talking about it from a perspective of an organization might have hundreds or even thousands of machines that they need to monitor. And if you think about that, it becomes very quickly a challenge as to how customers will do that or how organizations will do that. And so many organizations look at a tool like a log aggregator, or even what's called a SIM, a security incident and event management system, that will gather all those logs from all the hundreds or thousands of the machines that they manage and pull them all into one place. And then that log aggregator or SIM will analyze those logs automatically and point out anomalies so that they can then be investigated by security folks. And that's really one of the cruxes of what cybersecurity is looking at systems, looking at the logs on those systems, and then getting automation to aggregate those logs as well as analyze those logs to look for events that may need further investigation.
In this video, you will learn to describe auditing and access control for Windows Server.
So another facet of cybersecurity is around auditing. And when we talk about auditing, it's establishing a policy and looking at monitoring the creation or modification of objects to track potential security problems. When we talk about monitoring objects, we're talking about typically files or folders, and in this context on a Windows system. And it does really a couple things. It helps ensure user accountability, and it can help provide evidence in the event of a security breach. So let's dig into that a little bit. When we talk about user accountability, 50% or about 50% of cybersecurity events are internal, meaning that it was caused by someone within the organization. Now, that doesn't mean that every single security event that is internal is caused by a bad actor. It could very well be that someone clicked on a link accidentally or didn't know any better. So it's user, for lack of a better term, ignorance that may cause a lot of security events, because cybersecurity bad actors are getting very sophisticated in what they can do. You know, you'll get emails that say click on this link, that'll take you somewhere that downloads a file to your computer, and then hell breaks loose within the environment. So looking at things on a machine or on an endpoint or a server for monitoring that auditing of those objects is really, really important, because when you look at a cybersecurity event, it is mostly how they start mostly is a file is either dropped onto a system or is modified in order to start a chain of events that will cause some problems in the environment, some malicious activity in the environment. And from a Windows perspective, there are 9 kinds of events that you can audit. And those events are in the security log, which we talked about a little bit earlier, which is parsed into the Windows event log, or I should say the Windows event viewer. And that's what most people will monitor in their Windows environment to check on these kind of events. And we talked a little bit earlier about how folks will use an event parser or a log parser or a SIM to look at those events. So the 9 kinds of events you can talk on are account log on events. So this is somebody logging into a system and logging in remotely is really what we want to make sure that we're auditing, because if someone if you look into a system and see that someone has tried to log into it 1,000 times within a second, you know, you're maybe an example of a brute force attack of someone just trying to check random passwords to see if they can log into the environment. You can also look at account management. So this can be audited when someone has changed an account name, enabled or disabled an account, or created or deleted an account, or changed a password. So if you notice that there are a ton of accounts being created in a very short amount of time, that may be something that has to be investigated from an account management perspective. And then directory service access. So when someone accesses an Active Directory service object, that has its own access control list as well. So if someone is trying to get into a particular system in the environment, like I said, multiple times in a very short amount of time, that might be an example of an event that needs to be investigated. And there are other events as well, log-on events. So when someone is trying to log on or off of a computer, either while physically at the computer or trying to log on over a network, and then again looking at how often that is occurring, if it's the same person, where that log-on is being attempted from, because with seeing the IP address, we can 99% of the time determine where that person is, at least within a specific geography. Obviously, we can't get to the exact desk where they are, but you can know, this is from a cafe in Somalia trying to log into a system that's located in Kentucky. We probably want to investigate that. We can also look at object access. So if someone has used a file, a folder, or a printer, or another object, and you can also, so anything that can be accessed with an Active Directory can be audited to see who accessed it and when and for how long. You can also audit policy change. So if attempts to change the local security policies and to change user rights assignments, those will be tracked within Windows and can be audited. So if I am a local admin on my machine and I go in and try to change local security policy to disable the password or to make the password less secure, that will all be tracked by Windows, and an organization can audit that to make sure that it's not being abused. And privileged use, so when someone performs a user right, that will also be tracked, and also track processes on the endpoint, such as when a program is activated or a process exit occurs. So as an example, if I'm an admin on my machine and I go into the task manager and stop the AV process because it's slowing down my machine, or I should say because I feel like it's slowing down my machine, that will be tracked within Security Center, and then I can audit that and ask, and investigate that. Why is someone turning off their AV, and take appropriate action? And that's just an example of the kind of things that could be audited within process tracking. And then system events. So when someone shuts down or restarts the computer, or more importantly, when an application or a program or even a process tries to do something that it doesn't have permission to do. And this could be an example of a security event where someone is trying to do something malicious in the environment. They're trying to have a process do something to access a remote computer or access a remote database or anything that it doesn't have the rights to do. It's the purpose of doing something malicious in the environment.
In this video, you will learn to describe why organizations use the Linux operating system.
Hello everyone, my name is Alex Campos. I'm CM Administrator in MSS IBM Security, and today we are going to start with the Linux course for beginners. So, Linux is a multi-user, multitasking operating system which provides a number of facilities including management of software, resources, directories and file systems, and the loading and execution of programs. The Unix operating system got started in 1969 at Bell Laboratories and was written in assembly language. Then, in 1973, Thomson and Ritchie succeeded in rewriting Unix in the new language that was C. In September of 1991, Linus Torvalds released the first version of what it was to become the Linux kernel. Torvalds greatly enhanced the open source community by releasing his license under the GNU license. The GNU license is a widely used for free software license which guarantees the end users the freedom to run, study, share, and modify the software. Now, why Linux? Well, the system is flexible enough to allow users to build applications with a wide variety of support tools such as compilers, scientific libraries, debuggers, and a network monitors. Linux has also four essential properties which make it an excellent operating system for science community. Performance, functionality, flexibility, and portability. The performance of the operating system can be optimized for specific tasks, such as running small portable devices or large supercomputers. Now, how does the Linux work? Well, there are two major components of Linux, the kernel and the shell. The kernel is the core of the Linux operating system, which includes the processes and interfaces directly with the hardware. It manages the system and users, processes, devices, and files, and memory. The shell is an interface to the kernel. Users input commands through the shell, and the kernel receives the tasks from the shell and performs them. The shell tends to do 4 jobs repeatedly. 1. Display the prompt. 2. Read the command. 3. Process and give in the command. And 4. Execute the command.
In this video, you will learn to describe the Linux directory structure.
Next, we're going to discuss how Linux and the file systems was designed or is designed. Let's talk first about files and directories. Files is a basic unit of storage for data. This unit is basically stored or pretty much stored on a physical media such as hard drive, a thumb drive, or anything that it's designed to store information. It's represented by a dash, and we'll discuss this later on. A directory, on the other hand, it's in a special type of file. A directory has information about other files, so it's like a container for files, and it's the equivalent of folders in Windows. In Linux, it's represented by a letter D in the command line interface. In the screenshot below, or the image below, you will see the highlighted directory that are on the first letters on your left-hand side. You will see that it starts with the D. That indicates that that specific item right there, it's a directory. But you will see just above that not a copy.txt. It starts with the dash, so that indicates that that specifically is a file. Linux and the directory structure is a lot different than what we're used to in Windows. Everything starts with the slash, also called the root, and everything else it's just quote unquote attached to the slash partition or the root partition. The slash partition, also called root, it's where every single file and directory starts from. Only the root user has write privileges under this directory, and that's supposed to be like that for security reasons. The slash partition, it's not the same as the slash root. The slash root is basically the home directory of the user root. We'll discuss home directories in a little bit. The slash bin directory, it contains binary executables, basically. Common Linux commands are found here, and we have a list there: ps, ls, ping, rep, cp, mv. We'll discuss a little bit more about basic commands in Linux in a couple of slides. The slash sbin, it contains executable binaries as well, but they're more related to system maintenance tasks like IP tables, like the reboot command, the fdisk, or the ifconfig, for example. The slash etc, it's where most of the times you will find configuration files for all the programs installed. If we have a Linux server and we install Apache on that server, for the configuration of that specific service, you will go to /etc/Apache, and you will find all the configuration files on that directory for specific applications. The /var, it's in a specific partition designed to hold files that grow or change constantly. It's referred as variable files. And a perfect example for these are logs. They're usually found under /var/log. So all the applications, or most of the applications that you will find out there, will create their logs under /var/log. The /tmp partition, it contains temporary files. So anything that you store under /tmp will get deleted when the system reboots. This is not meant to hold files like any other partition will do. Anything that is stored under /tmp, whenever the system reboots, will get deleted. The /home partition, it's the home directory for all the users. So whenever a user is created and it creates a home directory, you will find it under /home. This is designed to store personal files for each individual user. And this specific partition will only have privileges for this specific user. So let's say I created a user called Warren. That will be on the home directory for that user will be under /home/Warren, and only Warren will be able to edit or read files from that specific directory. Another important partition is the /boot partition. It contains bootloader files. This partition is specifically used during boot time.
In this video, you will learn to describe the run levels included in Linux.
Now we're going to talk about run levels. Well, what is a run level? When a Linux system boots, it launches the init processes. Init is responsible for launching the other processes on the system. For example, when you start on your Linux computer, the kernel starts init, and the init executes the startup scripts to start your hardware, bring up the networking, and start your graphical desktop. However, there isn't just one single set of startup scripts init executes. There are multiple run levels with their own startup scripts. For example, one run level may bring up networking and launch the graphical desktop, while another run level may leave the networking disabled and skip the graphical desktop. This means you can drop from graphical desktop mode to the text console mode without networking, with a single command, without manually starting and stopping different services. So as you can see in these slides, the run levels are represented by some numbers, where 0 will shoot down this system and shoot down all the services. The run level 1 is a single user mode, and the system boots into the super user mode without starting daemons or networking, and it is basically used for booting into a recovery or diagnosis environment. The run levels 5, 4, 3, and 2 are basically the same. It provides full multi-user mode with networking and graphical login, and the run level 6, it's used for reboot. So basically, I'm going to show here in my virtual machine. I'm going to be logging here, and so this is my virtual machine, and as you can see, I'm going to be running the run level 6. You can use reboot or just init and then the run level number. In this case, I'm going to be using 6 to reboot my system. So as you can see, I'm rebooting my system.
In this video, you will learn to describe the common shell choices within Linux.
Now we have the different shells here, but what is a shell? Well, the shell is a program that takes commands from the keyboard and gives them to the operating system to perform. In the old days, it was the only user interface available on Linux operating system, but nowadays we have graphical user interfaces like the GUI, in addition to the command line interfaces such as the shell. We have here 2 shells. That is the bash, which is the most common default shell for user accounts, and we have the sh. It is not often used in Linux, but it points to the bash shell or other shells as well. Part of that, we also include tch shell. The tch, this shell is based on the earlier C shell. It was fairly popular, but not major Linux distributions take it as the file shell. Then we have the CSH, that is the original C shell, but it's in use much on Linux. But if a user is familiar with CSH and TCSH, takes a good substitute. It is basically used for programs based on C language. Then we have the corn shell, that is known also as key SH, that was designed to take the best features of the Burning shell and the C shell and extend them. So it has a small but dedicated following among Linux users. Then we have the Z shell, that takes shell evolution further than the corn shell, incorporating features from the earlier shells and adding still more.
In this video, you will learn to describe internal versus external Linux commands.
We are going to talk about basic Linux commands. In Linux distributions, internal commands built into the shell program and are shell dependent, also called built-in commands, and determining if a command is built-in command by using the type command. So if you use the command type and then the command that you want to check, you will see a message. If you see shell built-in, it just means that it is an internal command. Otherwise, it will be an external command. So in conclusion, internal commands are commands that are already loaded in the system, and they will be executed at any time the system requires the command. Now we have the external commands. That are commands that the system offers, are totally shell independent, and usually can be found in any Linux distribution. And also they are mostly reside in the /bin and usr/bin as well. Now, before I continue with the external commands, there are some tricks that we can use in the CLI. For example, we can use the tab key in order to fill the name, and also we can use Control A or Control E to move the cursor to a start or end to the file. So, for example, if we can see here in my virtual machine, I have here some files under Home, A Campus C, Books. I have some books here, Math Test, and this is my test. As you can see, this is a long name. So if we want to see the information that is in this book, we can use tab to save some time. So I want to see the information that is under this file that is located under Home. If I just type HO and then tab, it will just fill the entire path. For example, if I can continue with a camp and then tab, it will fill up the rest of the name. See, so we can use the tab key in order to save some time and type very quick as well. Also, let's suppose that we made a mistake and we just want to go to the top. So we can just click Control A and we will be on the top here, and we can do the changes. Or we can just go back to the end of the line with Control E. So this is basically some tricks that we have here. Also, we can use history to see what commands we already ran. For example, if I just click history here, we will be able to see all the commands that we ran already. So we just can take one and run it again. Or we can just use this to investigate which commands were run during an operation system. Also, we can use up and down arrow to see the commands that we ran. So we can save some time here as well. Also, we have daemon. command that is used for the manual to see what a specific command do. For example, I want to see what the ls command do. So basically, we just do man and ls, and it will provide all the information about this command and what are the flags that we can use with this command as well.
In this video, you will learn to define basic Linux commands and their uses.
Now we're going to start with basic Linux commands that we can use on different distributions in Linux. We have the uname that will show what operating system is being run. For example, as we can see here, if we run the uname command, we will be able to see that we are running Linux. But if we want to have some more details, we can also add a flag -a, and it will provide additional information like the current Linux kernel being used, system host name, and the date as well. Also, we have the cd command that is used to go to the different directories. So for example, let's see this picture here, where we can see that we have a home and different directories like Alex, Jack, Eric, and those files also have more files in there. So let's suppose that we want to go to Alex. So we are in home. As this example, we have in home. So we just need to add the cd and the name of the next directory, and we will be able to go to Alex. If we are in home and we want to go to test, we just need to add cd, then the name of the next directory, that is Jack, and then the next directory name, that is test. So in this way, using cd, we can just move from different directories and subdirectories. But what about if we are in test and we want to go back to Jack? So we just need to go to cd space and 2 points, and it will return back to the previous folder. So in this case, we are in Alex, home Alex, and we are going to go back to home. So we just need to type cd space point, and we will be back to home again. But sometimes we don't really know where we are. So there is a specific command that we can use to display the information of the path that we are. So in this case, let's suppose that we don't know where we are. So we just need to type pwd, and it will display the path where we are located. In this case, we are in home, Jack, test. So using pwd will display the path where you are located. Then we have the tar command that is used to create a new archive file. If we want to create a new archive file, we just need to type tar and the flags that will tell us to create the archive file. Then we just need to add the name of the tar and the direction and the directory where we want to create that archive file. If we want to extract that information, we just need to type the tar command and also the flags that will indicate that we want to extract the information on that file. If you just want to see what information is in there, we just need to add the following flags that will be tvf and the name of the tar as well. Then we have the grep. This command is used for searches, for specific searches. If we want to print the match line along the with the 3 lines after it, we just need to use grep. Also, I'm going to show you here really quick with my virtual machine how we can use the grep. So in this example, let's suppose that we are under home A campus books, and we have the following books here: Carless, Match, Test, Math Test, and this is my test. So under the car list, we have this information. This is the book. This is the information that we have under this file. And we want to, let's suppose that we have a lot of more names here with dates. It is a big list. So we want to find out all the information about BMW. So using grep, we can do that. So grep -i BMW and the name of the file that we are looking for, it will display the information for all BMW. Also, if we want to look for all the files that we have, we can just use grep-r BMW, and we'll display all the information on all those files as well. Then we have the find command that is basically similar to the grep command, but it will find files with a specific name. So basically you just need to use the command find, then -e name and the name that the file that you're looking for, and it will display the path where it is located. So also can use find to find a specific file with the md5, or maybe you can use the find to find out a file with the extension, or also you can find empty files in a home directory as well. Then we have the ls command that lists all the directories contents of the files and directories and display file size in human readable format. Also we have the ls-ltr that is basically the same, but it will display more information, like the last modified time and also the permissions that that specific file has. It will be displayed in a reverse order. Then we have the gzip that is used to compress files. The command is gzip and then the name of the file that you want to compress. Also, you can uncompress the file by using a flag that is the -d and the name of the, of course, the name of the file that is already compressed. Here's an example. I just ran ls to see all the files that I have under books, and then I just zip the car list file. As you can see here, it just added an extension that is gz that represent a compressed file. Then we have the unzip command that is used to extract all the information that is on a compressed file. So we just need to use unzip and then the name of the zip file that is compressed, and we will be getting the information from that specific file. Also, we can just we just can see the information that is on that compressed file without unzipping the file. So we just need to use unzip, then -l and the name of the zip file. Then we have the shutdown command that is used to shut down the server immediately. For example, we have shutdown -h now, that it will be power off immediately the server. But maybe we just want to shut down the device, but not yet, or we just want to shut down the server in 10 minutes or 20 minutes. In that case, we just need to use shutdown -h plus 10, that will represent 10 minutes, 20 minutes, or maybe you need to restore the server in 1 hour and 30 minutes. So you just need to convert 1 hour and 30 minutes in minutes here, and you will be restarting the server in that time. If you want to shut down the device but then reboot it, we just need to use shutdown-r that will be rebooting the server. And if you want to force to check the file system during the reboot, we just need to add the flags -f R. So it will be checking, will force to check the file system during the reboot in the shutdown command. Any difference between shutdown -R reboot and init6? In other distros there was, but in newer distros they do the same internal process. So basically you can use shutdown -R reboot or init6 and it will be doing the same. That is rebooting or shutdown the device.
In this video, you will learn to define basic Linux commands and their uses.
Then we have the FTP. Both FTP and Secure FTP have similar commands to connect to a remote server and load multiple files. So if you want to connect to a remote server, you just need to use the FTP and the IP of or host name of that remote server, and you can then start downloading the information that you want to extract from that device. Then we have the PS command that is used for display information about the processes that are running in the system. So if you wanna see what is the process that is running for a specific service, you just need to use the ps-ef on more, pipe more. Or to view the current running process in a tree structure, you can use H option like ps-efh pipe more. Also, you can just use ps and it will display all the IDs of the different processes, and you just need to use ps then the ID of the process, and you will see all that information as well. Then we have the free command that is used to display all the information about the memory available in the system. So just running free, you will see all the total memory that your system has, also the free memory. But sometimes it's difficult to understand or interpret what are those values. So we can just add -G that represents the gigabytes, and you will see all this information in gigabytes. So if you want to quickly check how many gigabytes, you just need to run free -G. Also, you can use A if you want to see in kilobytes, or M if you want to see in megabytes as well. So the free command will display all the information about the memory used in your system. Then we have the top command that displays the top processes in the system. So if you want to see the information displayed by top command, you will see all the processes that are running on top of my system. Also, you will be able to see the CPU usage and memory as well. Now, if you want to display only the processes that belongs to a particular user, you can use -U option, and it will display the information of the processes that are running on that specific user. For example, if we run the same command here, of course, it will be showing the same information since I'm using the same user. But if we have a big environment where we have a lot of users, we can just monitor for a specific user by using this command as well. Now we have the df command that will display the disk space usage in our environment. If we use the -K, it will display the output in bytes. But if we use the -H, it will display the output in human readable form. So for example, in our virtual machine, we have here our partition in the f-h. We'll see all the information about the disk space usage in our environment. If we use the flag -T, it will display what type of file system is in use for every partition we have in our Linux distribution as well. Then we have the kill command that is used to end a process that is running on our environment. So if you wanna kill a process, it's really important to know first the ID of the process that is running. So using the ps-ef will display the ID and the process as well. So you just need to use kill-9 space and the ID of the process that you wanna kill. It's really important to be care of this, since as soon as you kill the process, it won't come back again. For example, in this case, we are trying to find out an ID for all the files that belongs to, or processes that belong to Beam. So we're just running the ps space-ef, and we're doing a grep for Beam to find out. In this case, it displays 7243. That is the ID of the process that we want to kill. So we just need to use kill space-9 and then the ID of this process, and it will be killed.
In this video, you will learn to define basic Linux commands and their uses.
Now we have the remove command that is represented by rm. It will, if we use rm to remove a file, if we use the flag -i and the name of the text or file that we want to remove, it will display the confirmation before removing the file. So this is very useful in case you don't want to delete or remove that specific file. Sometimes you have a directory that contains subdirectories, and you want to delete all the folder with all the information in there, but the system don't allow to delete until you add the flag -r that will remove all the files in there. If you don't add the -r, it won't let you delete all the information. So you just need to go delete one by one. So in order to avoid that, it is just simple than adding -r in the command. In order to remove a directory that is empty, we just need to use the rmdir command and then the name of the directory that you want to delete. Then we have the copy command that is used to copy files or directories. The command is cp. If we use the flag -p, it will preserve the mode and ownership and the timestamp. But if we use the -i, it will overwrite the information. So it is really important to make sure we're using the correct flag here. So in order to use the cp command, we just need to use cp, then the flag that we're going to be using, the file that we are want to copy, and then the file that will be overwritten as well. Then we have the move command that is represented by mv. And it's basically the same of the copy command. If we use the flag -i, it will overwrite the existing file. But if we use the -v, it will be explaining what is being done during the movement of the file. So basically, we just need to use mv and then the flag and then the file that we are going to be moving and the location of the file that will be saved or moved, the file. Then we have the cat command that will display the content of the text files. And also we have the mkdir that is used to create directories in the different path locations in our distribution. So if we want to use cat, let's see the information that we have under books directory. we want to see what is the information that this is my test file contain. So if we use cat and then the name of the file, it will display the information that is in that specific file. Then if we want to create a directory, we just need to type the command mkdir and then the name of the directory that we want to create. I'm gonna create test3, and if we run ls to see what is the information in there, we will be seeing the test3 created as a folder. Now, maybe you're wondering, what about if we want to create a directory with some subdirectories? Well, in this case, we just need to use the flag -p, and it will be creating all the subdirectories that you want to create as well using mkdir. Now we have the ifconfig command that will display all the information about the network interface on the Linux system. If you want to see all the interfaces along with the status, you just need to use the flag -a. If you want to start or stop a specific interface, you just need to use up or down command along with the ifconfig and the interface. So in this case, we're using ifconfig. It's number 0 and up. This means that this interface will be going up. If you just want to shoot down this interface, you just need to use down. Then we have whatis command. That it is very useful command. It will display a description about a command. So if you really don't know what that command is used for, you can use whatis and then the command name, and it will display the description of that command. So it is basically the same of the man command, but it will just display the description. The man command will display all the information and the flags that you can use with that command. Then we have locate command that it will help you to quickly search for the location of a specific file or maybe a group of files. So you just need to use locate and then the name of the folder or file that you are looking for, and it will display all the path files that contain the name that you're looking for. Then we just have the tail command that will be used for view the end of a text file. For example, the last 10 lines by default. You can print any number of files from a specific file. For example, tail-n, and then for example, we can use 4, 5, or any number of lines that you want to see of file name .txt, and it will just display that information from the last n number of lines you want to see. Then we have the less command that is very useful for huge log files. When you're doing a troubleshooting, for example, or investigation, and you have a very big logs files, and you just need to see all the information. With less, you will be seeing the information needed, and it won't display all the information at the same time. So if you hit the space key, it will be showing the information as soon as you hit the key. So it won't display all the information at the same time. So it is really useful for investigations with big log files. Also, you can use Control F or Control V to forward one window or backward one window. They are very useful keys and commands that you can use for investigations. Then we have the su command. It is used to switch to a different user account. So you can execute a single command from a different account name. So for example, in the following example, John can execute the ls command as rash username. Once the command is executed, it will come back to John's account. Also, you can use su command to just switch to, for example, my user, a campus to root user. So you just need to use su space dash u and then the user account that you want to switch. Then we have the wget command that is very useful to download software, music, videos from internet. Sometimes we have our environment and we need to do an upgrade, and instead of downloading the file from the internet, then copying the file to our environment, it is just simple to use wget and the URL where the software is located, and it will just start downloading the file directly to our system. So wget, it is very useful for downloading software to our environment without doing the copy and downloading the file in different ways. So those were some basic commands that we can use in our distribution. Of course, there are a lot of more commands that we can use, but those are the basic commands that we can use.
In this video, you will learn to describe the installation steps necessary to use Samba.
Now we are going to talk about Samba and the step-by-step installation. So let's suppose that we already have our virtual machine and we have our Linux distribution installed. In my case, I'm using the Ubuntu distribution. You can use CentOS or Linux. But what is Samba? So Samba is an open source or free software suite that provides seamless file and print services. It uses TCP ITP protocol that is installed on the host server. If you configure correctly this software, it allows you to interact with the Microsoft Windows client or server as if it is a Windows file and print server. So it allows for established communication between Linux and your server. So for example, I have here my Linux distribution and I just want to share files or information between my Windows host and my Linux server. So we're gonna learn how to do that. So basically, we just need to run the following commands on our Linux distribution, and we will get the Samba installation. Then, as soon as it is installed, we will see the following file that is under etc Samba, and we just need to do a backup of this file because we need to add some lines in there. So in order to do that, with the cp command, we're gonna copy the etc Samba smb.conf file under etc Samba smb.conf, adding that back extension that represents a backup. So as you can see here, I already did the backup of my smb config file. Now we just need to edit the file, and we can just use nano or vi to edit this file and add the following lines. We just need to copy this information and paste it into this file. It doesn't matter the order, but we just need to make sure that we have all the lines in that file. Then we just need to create a directory with the mkdir command. Our directory is under Samba and the name is anonymous. Then we just need to set up the permissions for this specific folder, and then restart the service that will allow us to establish the communication. The name of the server is Samba, so we just need to use service smbd restart. As soon as we do that, we just need to jump to the Windows host, in this case our computer, and under network folder, we just need to add the IP of our Linux box. In order to see the IP, we just can use ifconfig, and it will display all this information, the IP, the interface, and everything. If you want to create a folder, but with a password or secure folder, we just need to edit the same folder, the same file, but we just need to add the user and also the following lines to create a folder with a specific password. In this case, we are creating this folder with a secured name under Samba, and then we are providing the permissions to that specific folder. And also we are adding the following lines under etc Samba smb config file that was created during the installation of Samba. Then we just need to restart the service, and we will be able to see the secure folder in our Windows computer. And if you try to double click and access this folder, it will be requesting the user and password. So thank you guys for your attention. This was the basic Linux training. We just saw a few commands that we can run in different distributions on Linux. Also, we saw the way to establish communication between Linux environment and Windows host environment. So hope you can try to run some commands on your side and practice a little bit more about Linux.